Example 1. Look at the graphs given below. Each is the graph of y is equal to p of x, where p of x is a polynomial. For each of the graphs, find the number of zeros of p of x. Okay. So here 3 graphs are given and they are asking for each graph how many zeros are there for given p of x. Okay. We all know that in the graph, if you want to say how many zeros are present for the given polynomial equation, we have to see how many times the graph intersects the x-axis. Here, in the first graph, the graph intersects the x-axis at only one point, hence there is only 1 zero for this given equation. In the second graph, here the graph intersects x-axis at 2 distant points, hence there are 2 zeros for this equation. In the third graph, we can clearly see that the graph intersects the x-axis at 3 points, hence it contains 3 zeros. Okay. Now, fourth, here the line intersects the x-axis at only 1 point, hence the number of zeros in the fourth graph is 1. Now, coming to the fifth graph, here the intersections A1 and A2 both are equal and coincide at point A. So the graph again intersects the x-axis at only 1 point, hence the number of zeros present in the graph is 1 for fifth graph. And coming to the sixth graph, here the graph intersects the x-axis at 1, 2, 3, 4 at 4 distinct points, hence the number of zeros is 4 for sixth graph. Okay. Now, exercise 2.1. The graph of y is equal to p of x are given below, and for some polynomials p of x, find the number of zeros of p of x in each case. So again, they are given some graphs, and by looking at the graphs, they want to ask us to identify how many zeros are present for each graph. So from first graph, we can clearly see that the graph here cannot intersect the x-axis. So here the number of zeros is 0 for first graph. Okay. Now for second graph, here the graph intersects x-axis at only 1 point, hence here the number of zeros is 1. And in third graph, the graph intersects the x-axis at 3 points, so number of zeros is equal to 3. Okay. Fourth problem. Here in the fourth graph, the graph intersects the x-axis at 2 distant points, and the number of zeros is 2 for the graph 4. And coming to the fifth graph, here the graph intersects the x-axis at 1, 2, 3, 4 points, and the number of zeros is 4 for graph 5. Now, coming to the graph 6, the graph intersects the x-axis at 1, 2, and 3, hence the degree and the 0 is 3 for graph 6. Okay. Relationship between zeros and coefficients of a polynomial. Okay. We already know that the zero of a linear polynomial is ax plus b, which is equal to minus b by a. Okay. To find the coefficient, to find the zero for a quadratic polynomial, let us consider a quadratic polynomial. P of x is equal to 2x squared minus 8x plus 6. Okay. To find zeros, we have to make factors for this equation. Do you all have any idea about how to make factors? Okay. So, in finding factors, the first major step is identify the x term or the middle term. So here, the x term is minus 8x. Now, this x term can be split into 2 subterms in which it satisfies 2 conditions. That is, the sum of these 2 subterms, which is equal to the middle term 8x, and the product of these 2 subterms, which is equal to the product of 2x squared into constant 6. Okay. So, I can write this equation 2x squared minus 8x plus 6 as 2x squared minus 8x plus 6 is equal to 2x squared minus 6x minus 2x plus 6. See, if we are getting minus 8x and if you multiply, we are getting the multiplication value of 2x square into 6. Okay. Now, I want to take 2x as common, then I am getting 2x into x minus 3 minus 2 into x minus 3. If I am taking x minus 3 as common, then I am getting 2x minus 2 into x minus 3. If I take 2 as common, 2 into x minus 1 into x minus 3. If you equate this equation to 0, then we are getting x minus 1 is equal to 0 and x minus 3 is equal to 0. This implies x is equal to 1 and x is equal to 3. These are the two values for which the given equation 2x square minus 8x plus 6 becoming 0. Hence, x is equal to 1 and x is equal to 3 are considered as zeros for the given quadratic polynomial 2x square minus 8x plus 6. Okay. Now, observe that sum of its roots, that is 1 plus 3, which is equal to minus b by a, that is minus of coefficient of x divided by coefficient of x squared. And similarly, the product of its zeros 1 into 3, which is equal to the constant term divided by the coefficient of x squared. These two notes are very important. You should keep in mind so that we can make problems solving in the future exercises easily. Okay. Now, in general, if alpha and beta are the zeros of a quadratic polynomial p of x, which is equal to ax squared plus bx plus c, then we know that x minus alpha and x minus beta are the factors. So from that, if you want to find the required equation, then ax square plus bx plus c, which is equal to k into x minus alpha into x minus beta, so that k is a constant, k into x square minus alpha plus beta into x plus alpha beta. So here, this is the case. It is very useful in problem solving when in the question they are given the value of alpha and they are given the value of beta, and they said these two are zeros for a polynomial, for a quadratic polynomial, and we have to find what is the required polynomial equation. Then what we have to do, first step, we want to see sum of its zeros, that is alpha plus beta, and the second step, we want to find product of its zeros, that is alpha beta. Then by finding those two values, we can substitute clearly in the equation x square minus alpha plus beta into x plus alpha beta. Then we are getting the required polynomial equation. Okay. Now, its general form, sum of its zeros, alpha plus beta is equal to minus b by a, which is equal to minus coefficient of x by coefficient of x squared, and product of its zeros, alpha beta is equal to c by a, which is equal to constant term by coefficient of x squared. These two notes are useful when they given a polynomial equation p of x in the given question, and they find what is the sum of their roots and what is the product of their roots. So in this type, we have to compare the given polynomial equation with the standard equation, that is ax squared plus bx plus c, and we can find what are the values of a, b and c, and after finding the values of a and b and c, we can say that sum of its zeros is equal to alpha plus beta, which is equal to minus b by a, and product of its zeros, alpha beta, is equal to c by a. Okay. Example 2. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between zeros and the coefficients. Here in the question, they are given a quadratic polynomial and they want us to find the zeros for the quadratic polynomial as well as the relationship between the zeros and the coefficients. Okay. Now, so for finding zeros, we know that for a quadratic polynomial, we have to find factors for the given equation. The finding factors is nothing but we want to split the x term into two subterms in which it satisfies two conditions, that is the sum of these two subterms, which is equal to the middle term 7x, and the product of these two subterms, which is equal to the product of x squared term into constant. Okay, so I can write x square plus 7x plus 10 as x square plus 7x plus 10 is equal to x plus 2 into x plus 5. When I equate it to 0, then I am getting x is equal to minus 2 and x is equal to minus 5. So these are the two values of x for which the given quadratic polynomial x square plus 7x plus 10 becoming 0. Hence these two values are considered as 0 for the given quadratic polynomial. Okay. If you want to check the relationship between the zeros and coefficients, compare the given quadratic polynomial equation with the standard form of equation, that is ax square plus bx plus c. Then we are getting the value of a as 1 and the value of b is equal to 7 and the value of c is equal to 10. Now, we know that the sum of its zeros, that is minus 2 comma minus 5, sum of its two zeros, that is minus 2 plus minus 5, which is equal to minus 7, which is equal to minus of coefficient of x by coefficient of x square. We know that coefficient of x is 7 divided by coefficient of x square is 1. So it is satisfied. And now product of its zeros, which is equal to minus 2 into minus 5, the resultant is 10. And coming to the coefficients, constant term divided by coefficient of x square, that is equal to 10 by 1, which is 10. So these two conditions are satisfied. Now example 3, find the zeros of the quadratic polynomial x square minus 3 and verify the relationship between zeros and the coefficients. We know that if you want to find 0 for a quadratic polynomial, we have to find factors. So it can clearly in the form of a square minus b square. So I can write x square minus 3 as x minus root 3 into x plus root 3. That is, so if we equate this equation to 0, we are getting x minus root 3 is equal to 0 and x plus root 3 is equal to 0. Hence the values for which the total equation x square minus 3 becoming 0 are x is equal to plus 3 and x is equal to minus root 3. X is equal to plus root 3 and x is equal to minus root 3. Hence these are considered as zeros for the given polynomial equation. Okay. Now if you want to find the relationship between the zeros and the coefficients, we know that the sum of the zeros, which is equal to minus root 3 plus minus root 3, which is equal to 0, which is in the question, if you compare its coefficients, minus b by a. In the equation, when it compared to the standard form of equation ax square plus bx plus c, we are getting value of a is equal to 1, b is equal to 0 and c is equal to minus 3. So sum of its roots is equal to minus b by a, which is equal to 0, and product of its roots, which is equal to plus root 3 into minus root 3, that is minus 3, and here the product of roots is c by a, that is minus 3 by a, 3 by 1, which is equal to constant term by coefficient of x square.